This lesson is on simulations. Mrs. Chen claims that 50% of Valley High students walk to school in the morning. You survey the first 40 people who show up to school and find that 16 of them walk to school. Do you have any concerns about the study that was conducted? What can you conclude about Mrs. Chen's claim? Yes, the reason why we should have concern is because we surveyed the first 40 people who showed up to school, meaning that we didn't randomly select these people and there could be some potential bias. Even though our study was flawed, we can still investigate what kind of sample proportions you would expect to see if the claim of 50% is true. As a class, we will create a sample proportion distribution to estimate a margin of error, which in turn will help us to determine whether it is plausible that the population proportion is truly 50%. We just need something that operates randomly with the same probability as the claim. So if the claim is 50% and we need something to simulate a 50% claim, then we can use coins, because a coin with heads or tails would be a 50-50 probability. Each person will flip a coin 40 times and record the proportion of, let's just choose heads. We will be able to then have random samples for a sample distribution. This website, random.org, is fantastic when we're trying to do simulations. Because we have chosen to flip a coin, if you have a coin at home, that's fantastic, you can use that. Otherwise, we can go to where it says coin flipper. We want to flip 40 virtual coins. The type of coin that you want. Just because we're all familiar with quarters, I'll just flip 40 quarters. Press flip coin. And now what I want to do is count up all the heads. At this point, I ran 39 more trials for a total of 40 trials in this simulation. You always want a minimum of 30 trials, so I felt that 40 was sufficient. You are more than welcome to count all the heads for each trial, but of course I also did that for you to save you some time. So I counted up how many heads I got in each trial and recorded that number in a table. You'll see all of this information in about a minute. This is all the data that was recorded from all of the 40 trials. Now what we're going to do is take all 40 of those values and create a dot plot below. I went ahead and counted how many times each proportion appeared by color coding them to make it a little bit easier for me to see, and then I transferred all of that data onto my dot plot, and this is what I ended up getting. The margin of error formula determines an interval that contains 95% of all sample proportions. You have just made a distribution of sample proportions, but we only want to catch 95% of the dots in your distribution. So 95% of the total number of dots rounded to the nearest whole number. Because I have a total of 40 dots, 95% of the 40 dots would be 38 dots that I want to catch or capture from my distribution. Draw vertical lines on your graph that exclude about the same number of dots on the left and on the right so that you have only caught 95% of the data. These represent the bounds on your interval. Measure the approximate distance between your vertical lines and determine the midpoint between the bounds. So we know that we have a total number of 40 dots on our dot plot, and we said that 95% would be 38 dots. If I'm excluding the same number to the left and to the right, I'm going to exclude one dot to the left and one dot to the right. If I exclude one dot to my left, this would be my lower bound. And if I were to exclude one dot to the right, this would have been my upper bound. This means that my lower bound was at 0.40 and my upper bound was 0.65. The distance between them would be 0.25 and the midpoint would be 0.125 away from each, so 0.525. So going back to my dot plot once more, my midpoint would be at 0.525. What is the margin of error according to our simulation? Well, that would be the distance between my midpoint and one of the bounds, whether it's the lower or the upper bound. So 0.625 minus 0.525 is equal to 0.1 or 10%. My confidence interval would be my proportion plus or minus my margin of error. My proportion was 0.4 plus or minus 0.1, meaning that my confidence interval would be between 0.3 to 0.5. Therefore, I would conclude that I am 95% confident that between 30% to 50% of Valley High students walk to school. And because Mrs. Chen's original claim was that 50% of Valley High students walk to school and 50% does fall within my 95% confidence interval, I am going to fail to reject her claim. Simulations. A simulation is the use of a mathematical model to recreate a situation, often repeatedly, so that the likelihood of various outcomes can be more accurately estimated. Many tools are used to perform simulations. A lot of the tools that we use can be found on random.org. You saw that there was a coin generator, a dice generator, a random number generator, a deck of cards. All of those are examples of tools that we're able to use. We use coin flippers like our first example when we had a 50-50 likelihood. A dice roller can be used when we have a 1 in 6 likelihood. Playing cards can be used in a variety of ways since we have 52 cards, but we also have a category of 13 different types of cards, or we can break them up into categories of suits, etc. Whereas a random number generator will allow us to use any probability. Example, you arrive in your Enhanced Math 2 class and are greeted with a pop quiz. The quiz is 5 multiple choice questions, all with 4 choices, or 4 answer options. You know that you are prepared for the quiz, but Billy hasn't studied, so he ends up guessing on every question. And after the quiz, Billy tells you that he was feeling lucky today and thinks that he got at least 4 questions correct. Choose an appropriate tool and then perform 10 trials of the simulation to determine the number of questions that Billy answers correctly out of the 5 questions. Record your results in the table below. At this time, what I would like you to do is please pause the video and think about a way that you could run this simulation. One way we can do this, which is not the only correct way we can do this, is to run a random number generator. I know that on this multiple choice test, there are 5 different questions on it, and of the 5, there are 4 different answer choices. So let's say that they are answer choices A, B, C, and D, and pretend that it's consistent for the entire test. I'm also just going to, for the sake of simplicity, pretend that answer choice A is the correct answer for every single one of these. Regardless of what letter you choose, though, it's a 1 in 4 chance of you getting the correct answer. Then, since I'm running a random number generator, instead of using letters A, B, C, D, I'm just going to assign each of the letters a corresponding number, 1, 2, 3, 4. So for each of the questions, as long as the number 1 appears, then I would say that I got the correct answer. Now I'm back on the random.org website, and earlier we were looking at the games and lotteries to use the coin flipper. I'm just going to scroll down and go where it says integer generator. Now what I'm going to do is generate 5 random integers. This is for each of the 5 questions on my test. Then each integer will have a value between 1 and 4, since there are only 4 multiple choice options on this test. Then I'm going to format it in 1 column. Press Get Numbers. And here are my random numbers, 1, 3, 2, 2, 1. That means on this multiple choice test, Billy got 2 questions out of the total 5 questions correct. Now that was only trial number 1. Billy got 2 questions correct, which means that he got 3 questions incorrect, and the percentage correct would be 40% correct. What I'm going to do is run this trial 9 more times. To run this trial, I'm just going to press the Again button 9 times. This was trial 1, trial 2, trial 3, trial 4, trial 5, 6, 7, 8, 9, 10. Now transferring all of the data over from the random generator. Based upon your 10 trials, what would you say to Billy about the likelihood of him getting at least 80%? Explain your thinking to Billy. Well, I would probably tell Billy that it's very unlikely. I wouldn't say it's completely impossible, but of the 10 trials that I ran, there was not once where I got at least an 80%. Now then, Billy just tells me that he's skeptical of my simulation and says that the number of trials that I ran was too small. Running 10 trials just isn't enough for him. So then you're asked to place your data for the number of correct questions on the dot plot on the board and copy the class data on the dot plot below. So we are obviously not in class to do this all together. However, I've already run 10 trials, so I'll run about 20 more trials and we'll copy all of that information on this dot plot below. It asks to put a dot for the number of questions correct. So for the first 10 trials, I had 2, 0 correct. I had 1, 2, 3, 4 for 1 correct, and then I had 4 for 2 correct. Again, at this time, I'll be running 20 more trials for a minimum of 30. So what I'm going to do this time is actually run all 10 trials at once to make it a little bit faster. What I can do to change this simulation is to just generate 50 random integers, where each integer has a value between 1 and 4. That is for all 4 answer choices, A, B, C, and D. And I'm going to format it in 5 columns to account for the 5 different questions that are asked in each trial. So when I click on Get Numbers, then what I'm going to do is look at each row for each trial. That means that in trial 1 of the 5 multiple choice questions going horizontally, he got questions 1 and 2 incorrect, he got question 3 correct, and then 4 and 5 incorrect. So that means that he got 1 out of 5 for trial number 1. And again, I'm going to continually count all the times that he got questions correct through trial 10. So after counting them all up for each of the 10 trials, these are the number correct that I got. So I'm going to now transfer this information over to my dot plot. On my dot plot, I got 0 correct twice. I got 1 correct 4 times. And I got 2 correct 4 times. I'm going to run this trial 10 more times for a total of 30 trials. For the last 10 trials, I'm just going to click again and go ahead and count each row one more time. In trial number 1 of the 5 multiple choice questions, I got 1 of them correct. Now that I have all my information counted up, I'm going to transfer this data onto my dot plot. For my remaining 10 trials, I got 0 correct 4 times, 1 correct 5 times, 2 correct once. Now that we've run this trial 30 different times, let's answer Billy's question again. What is the likelihood that Billy scored at least an 80% on the quiz? Explain. At this point, the highest percentage that we got on this quiz in terms of the number of questions correct is a 40%. We ran the trial 30 times, and again, I'm not saying that it is impossible that you can get 3 questions or 4 or 5 correct. That is, of course, a possibility. However, based off of the simulations that we've run, it does appear that it's very unlikely that Billy would have scored at least an 80% or get 4 out of the 5 questions correct. The last question in this example, suppose the pop quiz had 10 true or false questions. Billy now wants to know how likely it is that he scores an 80% or above by randomly guessing. How might you simulate this scenario? You don't have to actually run a simulation, although you are more than welcome to. However, what I would like you to do is come up with some kind of simulation for this situation. Please make sure you have a clear and detailed simulation, as I will be reading through all of your responses for this question.